Good day, mga God. Today I'm going to explain or discuss the measures of shapes, all about skewness. Hello, my name is Yanaka Adrian Jeff R. This is for mathematics in the modern world. Measures of shapes, skewness. Skewness is a measure of the asymmetry of a probability distribution. It describes how the data points are distributed around the mean. Skewness is a method used to quantify a distribution's asymmetry. When a distribution's left and right sides are not mirror images, it is said to be asymmetrical. This is by turning 2023. Now, the concept of skewness was first introduced by Carl Pearson from 1857 to 1936, an English mathematician and statistician. Pearson coined the term skewness and developed the first measures of skewness, including 1. Pearson coefficient of skewness, 1905, and 2. Pearson's mode skewness, 1895. There are three types of skewness, mainly positive skewness or right skew, negative skewness, left skew, and zero skewness symmetry. So first, let's talk about positive skewness. It extends towards higher values. Next, negative skewness or left skew. Tail extends towards lower values. And lastly, zero skewness or symmetric data is evenly distributed around the mean. So to further explain what are the types of skewness, let me explain to you in the next slides. Now let's further discuss the negative skew. So what does it mean? Now, as what I have said earlier, the negative skew at its tail will be extended to its left. So the mode will be located here at the peak of its curve, and then your median will be somewhere here on the left side of your mode. Median, this is your mode. Then the mean will be located here on the left side of your median. The mean represents negative skew because the mean will be smaller than the value of your median, and that is why the tail of the negative skew will be extended to its left. Now, in the normal skew or no skew, it said that the normal curve represents a perfect asymmetrical distribution. It means that what your value of your median will be the value of your mean. Let's just say that it is located here, and your mode will be somewhere here. Now, let's proceed to positive skew. And as what I have said earlier as well, the positive skew and its tail will be extended here on the right side of the curve. Now, your mode will be located here at the peak of its curve, and your median will be somewhere here on the right side of the curve, and your mean will be located here on the right side of your median. It means that your mean is larger, and the value of your mean is larger than the value of your median. What is zero skew? A distribution with zero skew is symmetrical, with left and right sides being mirror images. Now, normal distributions also have zero skew, but any symmetrical distributions such as uniform or bimodal distributions will also have zero skew. To further explain what is zero skew, let's put it into a problem. Now, the problem is, suppose we have the following data sets representing the test scores of students in a small class. We have the data sets or the value of data sets of 70, 75, 80, 85, and 90. 1. Calculate the mean, median, and mode. 2. Determine if the distribution is skewed or symmetrical. Now, First, we should determine its mean. Now, to calculate the mean, we need to follow its formula, and the formula is Q. Now, let's replace all the value of the said formula. Now, we should add 70 added to 75, added to 80, added to 85, and lastly added to 90 over the number of your data sets. So what is the number of the data set? We should count it 1, 2, 3, 4, 5. So we have 5 numbers in the data set. It means that it should be split into 5. Split into 5. Right? Now, to answer all of this, we should add these data sets. So 70 plus 75 is equal to 145. Now, plus 85, 80 will be 5, 12. So we got 225 plus 85. We got 310. Now we should be add this to 90, and we got 400. Now we got the 400, which is the summation of all the data, all the values in the data set. Now, all we have to do is to divide the 400 or to split the 400 to 5, and its answer will be 80. Now, the second step is to know or to determine what is the value of your median. Now, the meaning of the median is the middle number of the data set. So, what is the middle value of the data set? It is simply the number 80. So, your median is 80. What does it compute? Now, the value of the mean and the value of the median is equal. It means that this means that this is a normal speed or even speed, or we should call this a zero speed, because the value of the mean is equal to the value of your median, and that represents your normal speed, or you can call it zero speed. Now let's go with the right speed. Now what is right speed or positive speed? A right speed distribution, also known as positive speed, is longer than on the right side of its speed than on its left. This skewness can be visualized through tails, which are longer, tapering ends of distribution, indicating that there are relatively infrequent observations at one of the extreme ends of the distribution. To further analyze this right speed, let's put it into a problem. Now, the problem is, suppose we have the following data sets representing the test scores of students in a small class. We have the value of the data sets of 70, 83, 84, 89, and 90. 1, calculate the mean, median, and mode. 2, determine if the distribution is skewed or symmetrical. Now, the first step we should do is to get the mean. And this would be our formula. Now, let's add those values in the data set. 70 added to 83, added to 84, added to 89, then lastly added to 95 over the number of the data sets, which should be number 5. Now, the next thing that we should do is to add it all up. Now, 70 plus 83, so we got 153 plus 84, 32. We got 237 added to 84 rather than 89. We got 16, then 4, 12. We got 326 plus last 895, so 11, 12, and we got 421. Now, the summation of all the data sets will be 421 over 5. Now, let's split the 421 into 5, and the answer would be 84.2. Now, the second step to do is to determine its median. Now, the median would be number 84 because this is the middle value of all the data sets. Our median is 84. So what does it compute? Now, as you all can see, the value of the mean is 84.2, while the value of the median is 84. Now, as you can observe, the value of the median is slightly higher than the value of the median. The value of the mean is slightly higher than the number of median. It is higher than 0.2. So back to the mean and the median. The value of the mean is slightly higher than the value of the median. It means that the mean will be on the right side of the median. So let's put it into a visual representation. Let's put it using the curve. So here mode. So let's put the mode here. But there are the mode will be repeated, but there are no repeating numbers, therefore there is no mode. But let's disregard, let's set aside that for a while. Now, your median will be somewhere here on the right side of the mode, and that is your median. And your mean is somewhere here on the right side of your median, because the value of your median is 84 and the value of your mean is 84.2, which is slightly higher than the number of your median. That is why it is positively skewed. Now let's proceed to the left skew. What is left skew? Or the negative skew. In a negatively skewed distribution, the tail on the left side, lower value, is longer, meaning most of the data points are clustered towards the higher end, and a few low values pull the mean down. To further discuss what is the left skew, let's put it into a problem. In the problem, suppose we have the following data sets representing the test scores of students in a small class: 60, 75, 80, 85, and 90. 1. Calculate the mean, median, and mode to determine if the distribution is skewed or symmetrical. The first step that you should do is to calculate its mean. Let's add 60 to 75. Added to 80, added to 85, lastly added to 90 over the number of the value in the data set, which is 5. That means that 60 added to 75 is 135 plus or added to 80, 200 and 250 added to 85 will be 300. 300 added to 90 will be 390. After we get the summation of all the data, all the values in the data set, we will split it to 5. Now, its final answer will be 7. Next is to find its median. So the value of the median is really the 8. The median will be 8. So what does it mean? The value of your mean is slightly lower than the number or the value of your median. To put it into to further explain or to further discuss this, you should put it into a visual representation. Your median is somewhere here on the left. That is your median. And your mean will be here on your left as well. Let's say this is 8 and this is 7. And this is an example of the negative speed or the left speed. I have prepared three additional problems to further discuss the zero skew, the positive skew, and the negative skew. Now, the problem is neighborhood 1 income data in thousands of pesos for the 6 families is as follows: 45, 50, 55, 60, 65, and 70. Calculate the mean, median, and mode of the dataset and describe the skewness of the distribution. Now, I have prepared the mean. Now, this will give you all the summation of the datasets and the value of the datasets over the number within the datasets. So here I got the value, which is the 345 over 6, and finally we got the mean of 57.5. Now, here the median of all the datasets is also 57.5. It means that the value of the mean and the value of the median is equal. Now, in a visual presentation, in a bell curve, the amount of the median is located here on the somewhere in the middle or on the right part of the bell curve, while and also the mean is also located to go. Let's put it into a visual representation. The median rather is located here, and the mean is also located where the median located at, because the value of the median is also the value of the mean, and that's why. So this is an example of zero skew or positive, rather normal skew. Proceed to another problem. Neighborhood B income data in thousands of it's supposed to be peso for 6 families is as follows: 35, 40, 45, 50, 55, and 150. Calculate the mean, median, and mode of the dataset, then describe the skewness of the distribution. Now, We have here all the summation of data sets in the mean to calculate the mean, all the summation of the data sets over 6. So we got 375 over 6. Then eventually the value of the mean is 62.5. Now the median would be 47.5. As you all can see, the value of the mean is larger than the value of the median. And I have prepared a visual representation of this. So the median is located here, or somewhere in the middle, or middle to right part of the bell curve. It represents the value of 47.5. Now, the mean is located here at the right side of the median because the value of the mean is larger than the value of the median. The value of the mean is 62.5. Therefore, it should be located on the right side of the median triangle. So this is an example of positive skew. Or the red skew. Now let's proceed to the last graph. Neighborhood C income data in thousands of pesos for 6 families is as follows: 20, 45, 50, 55, 60, and 65. Calculate the mean, median, and mode of the data set and describe the skewness of the distribution. Now, here all the summation of the data sets over the number of the data sets. So, the value of the summation of the data sets will be 295 over 6 because 6 is the number between the data set. Now, to get the mean, we will split the 295 to 6, and now we got the 49.2, and that is the value of the mean. Now, let's proceed to median. The value of the median is 53.5. So what does it conclude? So, the mean is lower than the value of the median. Therefore, in a visual representation, the median is here, somewhere in the middle. And then your mean is somewhere on the left side because the value of the mean is lower than the value of median. And that is an example of negative skew or left skew. In summary, skewness is a statistic used to measure the asymmetry of a distribution, with positive skewness indicating a right skewed distribution and negative skewness indicating a left skewed distribution. A symmetrical distribution has a zero skew with left and right sides mirroring each other. To further understand the measures of shapes, especially skewness, visit the link on the references given. Once again, I'm Adrian Jeff R. Villanueva. Thank you for watching and listening.